Okay, welcome to the webinar Getting Started with AWS OpsWorks. The webinar will last roughly 1 hour. After an introduction to the service with slides, I will do also a demo of it. In the end of the webinar, we will have time to answer some questions. Due to the amount of attendees today, I can't ensure every question will be answered. But I have with me Michael, my coworker, in the chat that will try to help me answer as many questions as possible also throughout the webinar. So feel free to ask anything at any point in time. The webinar will be recorded and put online if you want to view it later or share it. OpsWorks is an application management service. It allows you to model, control, and automate your infrastructure. It also helps you deploy your application source code. It is easy to start and learn, and you can expand the functionality of OpsWorks by providing your own configuration code. You will be charged only for the underlying resources on AWS, so OpsWorks is free as long as you run on AWS. If you want to use OpsWorks to also manage infrastructure of other cloud vendors or on-premise servers, we will charge you 2 cents an hour per instance. But there's also another way how you can look at OpsWorks. OpsWorks is the service that follows the idea that infrastructure should be code, because code is reusable. It is a kind of documentation. It can be versioned, and it also can be tested. And all of this should be true for infrastructure as well, especially if you run infrastructure at scale or in a dynamic environment. So OpsWorks helps you to keep up with your business and growth needs without losing speed and details in your daily operations. So it reduces the manual and repetitive work and therefore errors. But let's introduce myself first before we continue. I'm Thomas, the Technical Program Manager of AWS OpsWorks. I'm with AWS for now over 3 years and should be, as one of the co-founders of the service, be able to answer all your questions. Before I jump into the details of OpsWorks, I want to help those of you that might have heard or even used other services in AWS to understand how OpsWorks relates to them. OpsWorks is part of the application management services. AWS offers these 3 services that address different areas and use cases to manage your applications. Elastic Beanstalk is our platform as a service offering. So it offers you containers and predefined elements that run your code artifact. And so the only thing you have to do is point your code against Beanstalk, and Beanstalk will take care of the rest. Everything is done and should be really, really simple and easy. OpsWorks is, if we think of a scale from convenience to control, is a little further right on the axis, so more into the control area. So it's about the automation, and it provides you a complete application lifecycle framework. So you have still direct access to the machine, and you can fine-tune everything. Even further on the right, there's CloudFormation. And for me, CloudFormation's one sentence description would be, it's a service that takes a JSON-based description of your infrastructure and creates or updates it for you. You can use all of them in combination. What do I mean by that? So for example, both services, Beanstalk as well as OpsWorks, can be provisioned through CloudFormation. So you would describe how you want to configure Beanstalk and instantiate it via CloudFormation. Or you can do something like this, which actually quite some of our customers do. You can create an OpsWorks stack together with all other AWS resources it will use in CloudFormation, and then use OpsWorks for your daily work. You should consider this scenario if you want to create and manage other AWS offerings in conjunction with OpsWorks. For example, you might want to create SQS queues, VPCs, and S3 buckets together with your installation or environment. But this will soon, on very fast, get to very advanced use cases already. So let's step back and start with what I called earlier in the slide, an OpsWorks stack. In OpsWorks, you organize your project stages or environments in something we call a stack. A stack will be a group that organizes all AWS resources and EC2 instances that belong to a specific project or something similar. So a stack can be your developer's playground, a staging, or a production environment. It can be a specific SOA component in your larger infrastructure, so for example, shared search or logging setups. It could be the installation or instantiation of your infrastructure for a single specific customer. So for example, your business could be to run content management systems for your customers, and each of the customer will get his or her separate installation so that it can be scaled and charged for independently. Anything that belongs together in a meaningful way should be a stack. You then can assign resources to a stack and put so-called layers inside. A layer is a blueprint to configure and manage your instances in the same way. So you would, for example, configure on an application server layer the details about your app server's framework and how to install it, the connection details for a third-party logging service, or the configuration on how to actually deploy your app to these application servers, or how to configure your security groups for all these instances that are on the same layer. After you have kind of sketched out your infrastructure with layers and assigned the resources, you just drop in the actual instances you want to use and you should be ready to go. We offer Buildin Layers that configure commonly used technologies. If you miss something on the list, you can always at any point in time create your own layers from scratch. You can also check out GitHub or just Google the technology or framework you're missing together with OpsWorks, and you should be find something. This is because a lot of our customers open source their configuration scripts, which is something we really like, as usually it is not your core company's value to have the best way to set up an Apache server. Your business usually is something very different, and everybody can benefit from what you have learned on the way to manage your Apache, and you also can learn from what others have done and benefit of this. Before the webinar, I did some quick search for things that were top of my mind and found the following. Scalable Python application deployments with AWS OpsWorks. Or you're looking for an ELK stack, so the combination of Elasticsearch, Logstash, and Kibana, and you will find all the configuration and a guide on how to do this with OpsWorks in just 15 minutes. Or you just want to manage your Docker containers, or run your favorite NoSQL database. These and many other technologies work with OpsWorks, and you will find details about that online. OpsWorks also provides, next to the built-in and the custom layers, a deep integration with AWS offerings like RDS, ELB, CloudWatch, and IAM. In addition, you always can hook up OpsWorks to any other AWS offerings by making the use of IAM instance profiles, the API, and your own scripts. If you are interested in that, we have several demos and talks about that at reInvent or other AWS summits, and all of these should be recorded, and you can find the code on GitHub, and you should also be able to find the slides and the videos. I also get asked a lot, how do I use OpsWorks to integrate with Jenkins or GitHub directly, or Travis CI, or CodeShip, CircleSnap? Like, kind of, there's a bunch of these services out there. All of them have built deploy hooks or like hooks into OpsWorks, and you can find easy to follow guides online about this. Okay, let's start and go a little bit deeper in the technology, like kind of how is all that magic I kind of talked about actually possible? How does it work? Let's have a look behind the curtain. The OpsWorks agent. The core of OpsWorks is an agent we put on every single instance you manage with OpsWorks. That little piece of software talks to our service and can execute commands. In addition to that, it also sends a heartbeat from the server and host level metrics to OpsWorks. The commands that agent reacts on describe important events in an instance's life. So there's a setup event to get a server from the plain vanilla state to become a web server or a database or whatever you want it to be. The configure event, which updates the server's configuration on changes in the stack. This allows you to react to changes so that you can, for example, scale up or switch database when the primary database crashes. The deploy and undeploy events you use to get code on and off the machines. The shutdown event to trigger is used to trigger a script to ship your last logs before the instance goes offline, or you want to have some cleanup tasks be done on the instance before you turn it off. So let's visualize that lifecycle idea a little further. So I have here an application server and like a graph, what happens over time from left to right. So at some point in time, the app server is created. So you need that, and you define that server layer in OpsWorks, and you create an instance. As soon as you launch that server, we start an instance based on your kind of description, and launch that instance on EC2 for you. We install our agent and get something on it which is called cookbooks. I will explain it later in detail. Everything gets installed, and the things that are described in your configuration script will happen. So like for the Buildin Layers, all of this is done for you. You can extend that, or you can write your own, as said before. So that would make the server install a Rails environment, for example. In the end of that process, the server is a working application server, and the configuration log or setup log is sent to S3, and OpsWorks is informed about that change, so that server is ready to use. What happens then is that OpsWorks understands that there was a change to the stack and triggers all available instances to execute a configure event. In our case, this is only one instance in our complete stack, so that very instance we just started will receive a configure event, and we will have another configuration event on that machine that just checks whether everything is as the desired state, right? So it's a the configure event is the one that checks if a change on the stack needs change on the instances as well. So in that case, this will be a no-op. So you now then can just deploy an app. So you trigger the deploy event, and that deploy event again executes scripts, and these scripts probably pull down your source code from wherever that lives, and run a couple of scripts if you need that to configure your app correctly, and restart the app server if needed, all of this, and your app should be running afterwards. Then the same thing happens. The event is reported back to OpsWorks, logs are shipped, and that state change is reflected in OpsWorks as well. But you're usually not done by just having plain application service. So like what happens if you would add a database server? So this database server would live in a different layer, in the database server layer, and you would define the instance there and actually start the instance. So the same procedure starts, right? We request an instance for you, we put the agent on the machine. That agent goes to the setup event. This time the setup event does something else than before, because it's running the scripts that are assigned to the setup event of the database layer, not the application server layer. So this will make the database become a database. After that, it will upload the logs again and trigger a configure event on the stack. The configure event in this case actually gets interesting, because the configure on the database server, probably not so much, but the configure event on the application server now actually gets useful, because the scripts that you have assigned, or we in our Buildin Layers have assigned to a configure event, check whether there is a change in the database connections required. So in that case, we will let's assume the app server is a Rails server. So in Rails, you have something that's called a database YAML file, which stores the configuration to how to access your database. This configuration would now be updated to reflect that there now is a database server. So we will add the IP address and connection details to the database YAML for you automatically. And without your manual intervention, that application server now is aware of the database server and can use it. So you could trigger deployment again and actually deploy an application that would make use of a database as well, and not just a static one. If you do that, you can trigger the event on both machines in the stack. That doesn't mean that the database server actually will download the application source code. It only means that this kind of event is triggered on the machine. The database server's deploy event might be a no operation, or it might be validating that the database schema is up to date, or it might be validating that actually all the application servers you have defined also have access right to the database. You can run something on every event, but you don't have to. For the application server, the same stuff will happen as before. It will pull down the newest version of your code and deploy it, and in the case needed, restart the application server. So all of this was really good, and you attract more customers, and your application is starting to take off. So you could add a second application server in the same application server layer and also launch that one. Again, by now you should get the pattern, like kind of the application server will be installed and configured. After that, a configure event is sent down to all the machines. Again, that might be not super interesting, as the older application server already knows about everything. Yes, there's now a new application server, but usually application servers don't chat between each other or don't have any connection or dependency on each other. But maybe if you manage on configure events, your database's access control list, that configure event would come in handy, as it would now take in the IP address of the second application server in the access control list, for example. You at any point in time can run any subset of what is described in the slide as recipes. So you can, and recipe is basically, you can imagine that being a script. I will explain why this is called recipes in OpsWorks in a second. So at any point in time, outside of the lifecycle event, can trigger any subset of configuration script on any subset of machines. You can use that mechanism to do something like backing up data, every night request or ship off or logs from the machines to some place, do remote work on the machines, like update certain packages, this kind of things. Usually load is dynamic on your app, and let's say like kind of it's in the middle of the night now. You don't need the application server anymore because fewer people access your application, so you can shut it down. And what will happen is that triggering the last kind of event I've described before, the shutdown event. And the shutdown event will do, as said, cleanup jobs, but it will also trigger a configure event again. So as said, any change in the stack will trigger configure events. And the configure events then clean up configuration. Like as I said before, if you manage with the configure event in the database layer your access control list for the database, your database will now remove the one IP address it doesn't need to give access anymore, or grant access anymore. So that is the basic idea of the lifecycle events and having different or separate layers. So what you end up while kind of planning your infrastructure is probably something like a matrix where you have the different types of layers or like kind of functions in your environment, in your stack. And you will assign certain scripts to run at certain like kind of lifecycle events. And I said before that scripts are actually called recipes in OpsWorks. And this is because OpsWorks did not reinvent the wheel, but is using Chef on the instances for that. Chef is an open source configuration management framework. The code is organized in something called a cookbook, which includes a selection of recipes. So like all the names make sense, right? Chef, cookbook, recipes. So think like an Apache cookbook with different recipes. One for setting it up, one recipe for managing all Apache modules, one for configuring the virtual host configuration, and so on. Like this is roughly the idea. So you have a cookbook around Apache and then different recipes to manage different aspects. And these recipes you would then assign to the lifecycle events. Chef is using a Ruby DSL, and you'll find a lot of resources on how to use Chef on the web. It will now shortly, I will now shortly prove that this is nothing scary, and everybody could do that, although you might not be familiar with Ruby or you never have heard Chef so far. Okay, I talked about Apache, right? So this would be probably the very first recipe you write, and you just say, I have a recipe that is called setup.rb. That's the Ruby ending of the file. And what I want to do is I want to install the package Apache. And you're done, right? That sounds really doable, right? This will install the package. The keyword package in here, in that like kind of one-line script, is a so-called chef resource. And this is the beauty and the magic of Chef. That resource actually knows how to achieve that task and how to install a system package on any kind of operating system. So it will actually do something like apt-get install on Debian style system, or it will use yum on Red Hat flavored systems. There are many Chef resources out there. So this would be an example for cron. Like all the resources, they share basically that they have attributes and actions. So you can specify details about that. So on the right side, you see I will create a cron job that is called daily report. Should run at minute, hour, day, like kind of as you would describe cron, that weird syntax everybody Googles all the time. You can, in the attribute command, define which report to actually run, or like which command to run at that point in time. And then the actions are something like create, update, remove, or delete, depending on the resource. There are many, many, many resources out there that you can use to create files, to create folders, users, basically everything you can do on the command line, including running just simple bash scripts. There are resources for that wrap that logic and make it work on different kind of operating systems. So coming back to our recipe, you probably would make that more explicit, right? So the default action for package would be obviously install, but just to make more obvious what's going on, you can say package Apache 2, do action install end, and it will be obvious to everybody what is happening. But you might also know that Apache is called different in different operating systems, like the package itself. So you might ask yourself, like, what do I do if I want to share my company that like configuration and setup of Apache, but like parts of my company are running Amazon Linux and some other parts of my company running Ubuntu. So this is where you kind of learn and grow and like kind of understand Chef more in detail. And you can do simple stuff like that where you say like, I have a case statement that based on the platform. So Chef is always aware of the context it is running. And to that context, OpsWorks also adds additional information about the current stack and all the state. So all the other application servers and their IP addresses on all of this, and also custom data you want to provide. So this is fed into every Chef run on the instance. So you can check for like in your recipe yourself, you can check. In the case I'm a CentOS, Red Hat, Fedora, or Amazon operating system, the package name, which is now an attribute of the package resource, actually is HTTPD. And in the case I'm on a Debian Ubuntu flavored operating system, the package name is Apache 2. So you now have a bulletproof installation of Apache 2 independent of your actual operating system. That's pretty neat. Okay, let's stop at that point and go to the demo of OpsWorks to actually show you how that looks like in the interface. Let me switch to my browser and go one step back. So I'm logged in with my personal account, and what you see here is all the console and all the different services. You will find OpsWorks here under deployment and management. As I told you before, we have a couple of services here. And by logging in, you will get a dashboard where you see the existing OpsWorks stacks you have already. In the case you have not a single stack yet, you will see a welcome message, or you see like, this is the video, this is the introduction to service, this is how you start, this is what the service offers. As I already have 3 stacks here, this is not shown to me. But nevertheless, start from scratch by creating a new stack. So this will show me a form where I can give this stack a name. I will call it webinar. I can choose in which region this stack should be. I can select in which VPC I want to put that stack, what the default configuration for my instances in that stack should be. I can override all these settings on the individual instance or even on the layer kind of hierarchy level as well. So it's just defaults. I select the IAM role OpsWorks is using. So OpsWorks is managing the infrastructure on your behalf. You can change that IAM role to restrict access for OpsWorks, so you can basically make certain actions of our service not available to your developers if you want to do that. You can decide if you want to have a default key on the machines. As said, you can override that on machine level. You can also define which default IAM instance profile should be used for the machines. I shortly mentioned that before. IAM instance profiles are a super powerful tool, and if you don't know what that is, I highly recommend. That is the one feature that blew my mind in IAM. So it basically allows your instances, without the need of you to provide any keys on the machine, to access very specific calls or basically APIs in AWS. So this is a way to treat an instance like a user, and you can define exactly what this user or this instance is allowed to do in terms of API calls. So you can make your application service, for instance, upload user-generated content or pictures to an S3 bucket, but you can restrict it to that one certain bucket, and you can restrict it to only save the pictures, but never kind of delete them, that kind of things. You can choose a host name theme if you want to. If you just have play around, I can call all my instances after fruits. You can select a stack color if you want to identify like different parts of your system or different customers or staging versus production, this kind of things. And in the advanced tab, you will find the underlying details around Chef and which Chef version is used on the machines. So let me create that stack. So the stack is created, and I will follow up by kind of going deeper into the definition and say, you know what, I actually want to deploy Rails applications. And I select the Rails application server layer that is pre-built. As said, we have a couple of pre-built ones. If you want to build your own, you can build your own layer. These pre-built layers, they expose a couple of settings that are already there for you, and also use recipes we have written already. So if you go to the details of a layer, you will see the general settings if they're available. You will also see the recipes that are used and assigned to each of the lifecycle events. As I've said, this is the blueprint. Every instance in that layer will behave the same. So the same recipes are executed during the lifecycle events. You can even click on the events or on the different recipes, and you will end up on GitHub and see what we do on this step. So you can read up what we are doing. You can use your own chef recipes and reference your own cookbooks to extend or override what we are doing if you want to. There's more settings on the layer, like network-based settings. You can say, I actually want to assign public IP addresses to all of the instances that are started in that, or even elastic IP addresses. I want to have an ELB in front of all machines, and OpsWorks will take care of putting all the machines that are in the layer also in the configuration of the ELB for you. You can also configure EBS volumes. So let's imagine that all your application servers actually should be EBS optimized instances as well. And under the mount point, vol logs, you want to have, because you're writing crazy amount of time, crazy amount of logs, you actually want to define a RAID 10 EBS based, or an EBS based RAID 10 with 4 disks of a total size of, I don't know, 80 gigabytes. And I want to use the SSDs. So I have a definition that then OpsWorks will create for you on every machine. So this is the layer configuration. We have kind of created that one Rails application server layer. We have attached the ELB in front. Like for my demo, I would also use either, I could use an RDS instance and like kind of import that RDS instance, or I can also go like, you know what, I want to use the OpsWorks provided MySQL layer instead. Doesn't matter. I can have this. And the only thing I now need to do after I've configured everything is to actually add infrastructure to it. So I go to the Rails application server and I want to add an instance that's called Blood Orange. You remember I chose the food-based hostname theme. Can select the instance size, which subnet. I can have different detailed overrides, as I mentioned before. And I could create a couple of application servers, and then I start these servers, and these servers then are requested on EC2, and the lifecycle system I explained before will start. I will do one more thing here. I create another one called Orange. And going to the MySQL layer, what I can do is I could add Orange in the MySQL layer as well. So what's happening here is, as I said, a layer is only a blueprint. I can assign instances to multiple layers. So what happens then is that the instance is executing the setup events, or the setup, the recipes that are assigned to the setup events of all the layers. The instance itself is assigned to. So this server called Orange would become a Rails application server and a MySQL database if I start it. So that's basically the small, like, kind of how to set up stuff. What OpsWorks offers you as well is two other things: time-based and load-based configurations. So you can say, I have a predictive load pattern, so I can add a couple of machines to my Rails application server layer. And I know that every day, 12 p.m. Up to 6 p.m., more people actually access my application. So I want to be prepared for this, and I have now defined that I want to have 2 more instances that run at that times of the day every day. I can then say, you know what, but actually on Friday, people don't use it that long, so I remove these 2 boxes a day, and the schedule for Friday is then different than from the rest of the days. You can also define load-based instances in OpsWorks, so you can say, I want to have a couple of more instances, and go to the configuration of the load-based instances for Rails application server layers, and you can tell us how fast to ramp up or how fast to kind of remove capacity again. And also define, like, kind of what should be the threshold for how much time should be kind of the metrics should be understood or exceeded for, like, kind of how long. So how fast you want to react to load spikes, how long you want to ignore load metrics afterwards, and kind of can do all this kind of configuration. So going back to the instances, I've defined a lot of instances, like Peanut, the instance I've defined in time-based, already realized it's supposed to start, so OpsWorks is requesting that instance for you automatically. I will click through a couple of more things. On the left side of the navigation, we have been at the stack level layer, instances, application. So an application OpsWorks is basically the reference to code. Like, I a Rails layer, so obviously I want to probably deploy a Rails application. You can deploy any kind of artifact or application if you provide the deployment related cookbooks for that as well. But in that case, I've created a Rails layer, so I probably also want to deploy the Rails application. So that's one of the Rails applications we have created for demo cases. So I just copy from GitHub the deploy URL, or the kind of clone URL. Sorry, not here, database, and put it in Git. Like, kind of, I chose Git as my source control system. You can also choose Subversion, HTTP archive, or S3 archive, or any other. Other would mean that you would also then again have to provide your own deploy recipes that then get triggered on the deploy event and make use of that keyword other to understand that you, for instance, like, kind of just secure copy from a location on a different machine or whatever you want to do, deploy via BitTorrent, or I don't know. There's tons of different options. We allow you to build any kind of system you want to. The application will actually talk to the database orange, the MySQL database. I could also point it to RDS, as you have seen before. You can specify application environment variables if you want to. You can handle the domain names, and we would make sure that the virtual host configuration is set correctly. You could enable SSL and provide your keys here, or your credentials. So I would have created the app now, and as soon as the instances are launched and are finished with the setup, I actually could deploy it. Because I don't want to wait for the instances to kind of complete this task, I will switch to a stack I've created a little earlier today. So I go to the instances. I didn't pick the food-based naming schema, but I've done something very similar. I've created 2 application servers that are supposed to run 24/7, 2 that are time-based and should run right now. I also put an ELB in front of this. So as you can see, the ELB helped. So application servers are distributed, and the ELB picked it up, and OpsWorks was managing that for me. And the difference is in that, like, kind of demo case I created here, is that I actually used RDS instead of the built-in MySQL layer of OpsWorks. In the end, I've done the same. I created an Rails application. I also pointed it to the same repository as before. I specified the data source in this case to be RDS instead of MySQL. And I deployed it. So on a deployment, as said earlier, what we will trigger is just the deploy event, and this deploy event then runs the chef environment on the machine. And in what you will see in the logs, so you have for every event I've said, logs get sent, you can see what happens. So in that case, like it's a mission, it fetches the Ruby gems, it does the asset compilation of this, and restarts Apache because I used Apache here, and I'm done. So if I go to layers and go to my ELB, that actually now is pointing to the 4 application servers that use the database, and I can like images and can add new images, and then they are stored in the database, which is not best practice, but that's just for the demo purposes here. Yeah, so I have a deployment history with all the events I've done on the machine. What I have else in OpsWorks is the monitoring. So I have averages across all the instances in a layer that are then used for the autoscaling. What you can see here as well, if I zoom into the last 8 hours, that the one instance was running for quite some time, that I started the Rails application server 4 hours kind of ago. And I also configured the time-based instances to run one hour apart. And you can see this is obviously a setup event where the instance gets set up. Here I deployed or configured something. So you have the different metrics. You can drill in further and see the metrics, how they are next to each other as well. With a stack, they are attached resources. So if I would have configured volumes as I've done in the other stack, so let me go to that one. You see, you remember I created the EBS rates for the instances. And so all the EBS volumes on EC2 were created for me, and they're assigned to the different instances that are launching. And the stack I used here, I haven't done that, so there's nothing to see. You could manage elastic IPs and move them around between instances if you want to. I haven't done that here as well. And in that stack, I'm using RDS. So RDS is the resource of the stack that is basically now living in that stack and can be managed in that stack. What we can do as well is, or what you can do as well with OpsWorks, is having a very kind of detailed level of restrictions. So on a stack basis, I can decide which user gets access to that stack. So I can, for instance, deny any access to that stack to Howard because I don't trust him. Leonard, in the other case, should be able to deploy applications but not change the infrastructure, while Penny should be able to change the infrastructure, so add or remove instances, Same goes for Rajesh, and Rajesh and Penny also get SSH access to the machine, and you know what, Sheldon should be as well and should get SSH and sudo access and can save these changes. And what will happen again is it triggers a configure event on the machines to make that happen. So if I go to an individual machine like I don't know, Rails App 2, I see the history of events. And what I can see here is that since how long it took to go through the setup, that I deployed the application source code at some point in time, that I run a couple of other scripts over the time, and now I'm executing recipes on the machines, which actually will now add and remove access based on my definition beforehand. So what this event system and that script system allows me is a very high degree of automation and control. And the cool thing is all of this is accessible via the as well. So this is basically how the integration in Jenkins would work. So in Jenkins, you would kind of see for changes in your source code, and then Jenkins would do like a build or a test task or whatnot, and then it would run, I don't know, Ruby script or whatever language you like, and uses the API in that script to configure OpsWorks to deploy or just trigger deployment in OpsWorks. So you can build any kind of pipelines or complex systems interacting with each other. Like let's assume that there's an SSL thing coming up again. You probably heard all of about the SSL security issues recently. So this would allow you to easily patch that on all the machines. So let's assume like kind of your operating system then provided a new package. What you could do is you can run a command. So we have a couple of shorthands that basically reference certain recipes that we provide. So you could do run the command update dependencies, which actually is just a wrapper around the a recipe that does apt-get update, apt-get install, that kind of things on Ubuntu, or the appropriate on other operating systems, and say give it as command a comment and say I updated all packages. And you can select kind of just one of the machines and say like I want to try that on one of my application servers and see if that has an impact, or you can select all, because in my case that's just a demo page, no one cares. And this again like kind of triggers an event on the machine once the appropriate cookbook or recipes, and all the machines should have updated packages. So much for the demo of OpsWorks. And I'm switching back to the slides, because there's one feature I want to highlight in OpsWorks that I personally find very powerful, and that's like kind of the idea to have on-premises infrastructure, or like kind of create multi-cloud installations. That's usually only important for really large customers, but it was highly requested. And the idea is that you can use OpsWorks to manage infrastructure outside of AWS as well. So you, for instance, could run something like VirtualBox on your development desktop and have this one be managed through OpsWorks. So your development environment is always up to date. Or you can say, I have a couple of machines in my office that run like my monitoring screens on the wall. And these machines are managed by OpsWorks. And as soon as you want to update your monitoring wall configuration, you just push a deployment in OpsWorks, and suddenly all your screens in your office get the new version of your monitoring software. You can think of 1,000 use cases where you have situations where you want to manage infrastructure that's not living in AWS, and that's why we offered it. So The one really obvious one is to scale out of existing infrastructure. So you already have invested in machines that are in your office, like in your local data center, and you can't get rid of them so fast. But you have them, so use them. But now you can use one operations tool to manage them all. And you can even do something you couldn't do before, and that's why you looked into AWS probably in the first place. You can scale your environment based on your load. So you could do a scale out and distribute the load between your machines and have ad hoc infrastructure in AWS in the case you need it. Or I personally talked to a couple of customers that have a situation like this, where they have an existing data center and they kind of, the own data center folks, they just can't keep up with the growth. There's limitations in terms of space they can grow, that kind of really like space, like land or that kind of situations. And they desperately immediately need a solution to remove large chunks of the workload in the data center. So they come to AWS, but then they're looking for a tool again that is able to manage both worlds. So they could use OpsWorks to easily migrate out, like kind of easy to migrate environments like staging test environments out of their own data center to give them a couple of months more breathing room to in the end probably work out a way how to migrate to the cloud completely. Coming back to the piece, like you might think, oh my God, this is really, really complicated, but it's pretty much as easy as before, like the example I showed you with the operating systems. So in your recipe, what you call something like if node, and this is again the structure that is provided in the context of every chef run. If in the node cloud, the provider is EC2, you would log to the chef log. This is an EC2 instance and would let it be. And in the case that's not the, or like in a situation where it's not the case, so it is your on-premise infrastructure, you actually might want to run an additional recipe that configures a different configuration on the machines that are needed only on-premise, or the other way around. But basically that simple if node cloud provider equals EC2 is all you need to make that distinction in your recipe. Okay, and with that, I think I am done with my presentation part of it. If you want to keep in touch, we have a Twitter account that is called AWS OpsWorks. We also have a blog. So there's a couple of blogs actually for AWS. Under blogs.aws.amazon.com, you find all of them. They're for different languages or different technologies and areas. And then there's also one for application management where you will find blog posts for Beanstalk, CloudFormation, and us, and also for the code services, so like that were recently released, like Code Deploy. And also there's one like kind of thing I personally like to highlight. If you use the AWS consoles, on every console, very down in the footer, you will see a feedback button. If you click that, you will see a small form like this. This message goes to the console owners of that very console. So if you use OpsWorks and you miss a feature, you don't like something, or you do need something else, or like kind of by pressing that button and putting some text in there, that actually generates a mail for me that I personally will read. But just to make sure, this is a one-way channel, so I will get a lot of these mails, and they heavily influence our interface as well. But you most likely won't get an answer from me. But this is a very powerful tool for you to make us aware of features you need or changes you like to see in our consoles. So thank you very much for joining the webinar today. Please give us feedback in the end.